Let's read it. So this is one of those standardized test questions. Email contacts. Anita has a total of 28 email addresses of family and friends stored in her contacts. This is pretty unnecessary, so I could just not even think about that. Twice the number of family addresses minus the number of friends addresses is 2. Which system of equations can be used to find how many email addresses of family A and friends B that Anita has stored? Go ahead and try this on your own. Pause it. I'm going to start talking about it right now. And with a lot of these types of questions, your first option is just to eliminate A, B, C, or D, and then you can always just do the problem too. And usually that's a bit of a time management decision. And A represents the number of family contacts, B represents the number of friends. So if you go the elimination route, and if I really focus on this word, total, well, if she has a total of 28, then I look at what can and doesn't make sense. Well, that makes sense. A plus B is 28. That makes sense. But this whole minus B, since those two parts are sort of questionable, we can go ahead and eliminate C and D. I would not subtract there. And because A and B, as the multiple choice questions, match for the first equation, we'd move on to looking at the second. So then I reread this. Twice the number of family addresses minus the number of friends addresses is 2. Well, that means that we're going to subtract. So we've already eliminated these. And now, when I see this addition problem here in B, well, that's not reasonable. The only reasonable choice must be A. And if you will off to the side, just think about reading through this and doing it. Well, if she has a certain number of friends and family members, well, family and friends, and they sum up to 28, then A plus B equals 28. You could come up with this on your own. And then if I look at twice the number of family addresses, well, since family addresses is A, I could double that to get twice as much. And then the next word I read is minus the number of friends addresses is 2. So I'd minus the number of friends addresses, which is stood up with B, and then that's going to be 2. So if I wanted to just come up with the answer, I could as well. Write and solve a system of equations. Transportation. A coal barge on the Ohio River travels 24 miles upstream in 3 hours. The return trip takes the barge only 2 hours. Find the rate of the barge in still water. Now, I'll be totally honest with you. This is one of those problems that are kind of challenging, and maybe, pretty keen math student feels very comfortable with these, but a lot of math students just kind of like watch the teacher do this, and then they get to the quiz, they get to the test, and they're asking their teacher, will this end up on the test? And if the teacher's like, yes, then they're looking at this problem and they're trying to remember how to recreate it. But I don't know that you really have 100% understanding of it unless you do a couple of these. So my message to you is don't beat yourself up if this feels very challenging, even by the end of the problem, if it's not crystal clear. But keep on fighting that uphill battle and try your best. Off to the right, I'm going to have you draw a picture with me. And that picture is going to be, a barge traveling some sort of distance on the water. So if I want to show that distance, well, it's going to travel a 24-mile distance. And if it's going upstream, then that's going to take it 3 hours. So directionally, we'll just consider it moving in that direction. But the opposite trip is still just 24 miles, but this distance is only going to take 2 hours to travel. So I'm going to label this as upstream, and I'm going to label this as downstream. Now by choice, I'm going to focus on the downstream trip first. And the reason is I think it makes the math a little bit more clear. So if the barge is getting pushed by its own motor, and it's moving in that direction when it's going downstream. So it's, speeding along, and it's going to have its own speed, and they call it the rate. So it's going to have its own speed, and I'm going to call this the barge speed. We have no idea what the speed of the barge would be in still water. So this is in still water. So if there's no current at all, that's what it would be doing. But then we also are going to have a little bit of an extra push to it that's going to speed it up. And that's going to be, the current. And I don't mean current like what is happening right now. I mean current like the speed of the water pushing it faster. Well, when it's traveling downstream, it's getting a little bit of an extra push from the current. So I know its speed is going to be x plus y. Well, we know that all speeds are measured in some unit of time, some unit of distance. So in this problem, it's miles per hour. And if I looked at this, well, I could get rid of the hours if I could multiply by the hours and be left with miles. So I'm showing that these units are canceling out. So here's HR dropping out, and I'd be left with miles. So let's see what happens if we multiply that by the only other thing that has time involved. Well, here's 2 hours down here. So if I multiply 2 hours by this miles per hour measure, then I know that that's going to leave me with 24. So it's basically the distance, speed, time equation kind of being worked out. So if I look at the other one, well, I know that this one is moving at its speed upstream, but because it's fighting the current is pushing back on it and taking away from its speed. So here I'm going to have x minus y times 3 is going to be equal to 24. I've come up with two equations, and now we have a system of equations that we can solve. I'm going to distribute in the first one, and the second one, and I have two new equations. Now, pause the video, decide what you'd multiply it by. I'm going to start talking right now. I will triple this and double that, and not bother with multiplying by negatives because I know those will cancel out. Take the pause button, hit it. I'm going to finish this problem in a few seconds. But you can finish this on your own because it's just elimination now. Here's the work I did. And technically, you could stop here, because the only thing the question asked you was what was the barge's speed in still water, and you'd want to label that. And the point I'm making is, here's all the directions we were given. So this part in red, although not necessary, I do advise it. And the reason that I advise it, and at any point you need to pause this, to look at all the work you can. The reason I advise it is if that's 10 and 2, then plugging it back in lets you check your work. 10 plus 2 is 12, times 2 is 24, 10 minus 2 is 8, times 3 is 24. And you could also check it in the real problem too. Well, if something was traveling 12 miles an hour, then 24 divided by 12 would give you 3. I had that part backwards. If something was traveling 8 miles an hour, because 10 minus 2, 24 divided by 8 would give you this 3. And you could also check it with this 2 hours. So you could check it against a real world problem too. Like I said, these are challenging. Make this an O-Yo on your own question, and we'll see how that goes. And this will be the homework assignment.